invited to presentation next report Gennady Sokolov, Maxim Zalisky, and Yulia Petrova. Are you ready?
Yes.
Yulia Petrova, please.
Hello, do you see my presentation?
No, from telephone, yes?
Yes.
No, little, but you, I see.
Okay, thank you. I am from National Aviation University, Kyiv, Ukraine, and I would like to represent our work reliability assessment of the emergency notification and evaluation management system. The paper outline, motivation and state-of-the-art, objective of our research, main result, conclusion, and future scope. The rapid development of global industry simultaneously create and complicate new challenges of society. This trend has not bypassed the security sector. It's known that is in event of the fire, the source of ignition must be promptly and reliably detected by using a combination detectors and means of collecting and processing information. The task of analyzing the efficiency of the security system usage for the independent purpose begin to be solved by the design stage. However, there is no single methodological approach to determining the quantitative assessment for such system efficiency. The purpose of this article is to demonstrate the method for assessment the reliability of the security system based on the usage of the structural diagram of elements, placement of the security system, and statistical data on the reliability of individual elements, in order to be able to compare the efficiently for their application for their intended purposes. The conducted analysis proved that reliability, cost effectiveness, and risk of the harm to human health could be used to assess the effectiveness of security system. In this paper, the main attention will be paid to the reliability indicators. Now it's possible to measure and process significant amount of data, including trends in reliability parameters. Initial data for reliability assessment are usual operating time to failure, duration of repair, electrical diagram of equipment, structural diagram of element, and so on. These data are the basis for calculating such characteristics as mean time of failure, the probability of failure-free operation, the steady-state availability, and many others. In general, these characteristics are random, so for a more quantitative analysis of reliability, it's necessary to find not only the mathematical expression and variance of these characteristics, but also the probability density function. We will consider the reliability calculation method using special example of the security system designed for a particular building. The building, which should be equipped with design emergency notification and evacuation management system, has a very simple structure. It has only 3 floors and a basement. All floors have the same area, it's about 650 square meters, and they are rectangular in plan. In the figure 1, you can see the example of placing detectors on the first floor, and here we have 3 different types of loudspeakers, each represented by different colors, and it depends on the area of the room. All notification zones have independent intercom system. The technical characteristics of the system components are known. To assess the reliability of the equipment of the design notification and evaluation management system, it's necessary to determine the criterion according to which the system is considered inoperable. The criterion depends on the system requirements, and let's formulate this criterion. The system is considered as inoperable if it doesn't transmit an alert signal to at least one of the notification zones. The system is considered operating if at least one loudspeaker in each notification zone has not failed. All zones are connected in series, as you can see in this figure, so that the system becomes inoperable if at least one zone or control and display unit fails. To calculate the probability of failure-free operation of the system, it's necessary to know failure-free operation function of one component. In this case, of the assumption of elementary failure law and exponential distribution law of time between failures, the probability of failure-free operation of loudspeakers, control and indicated units are represented by the formula 1 and 2, where T sub 1 and T sub 2 are loudspeaker and control and indicator units mean time between failures, and probabilities of failure-free operation of the loudspeakers of each notification zone are represented by the formula 3, 4, 5, and 6. The probability of failure-free operation of loudspeakers of the 4 notification zone and the probability of failure-free operation of notification and evacuation management system at whole are represented by the formula 7 and 8. An important characteristic of system reliability is the steady-state availability. It characterizes by the probability of the system being in operating condition at a random point in time remote of the start of operation. Consider the technique of determining the statistical characteristic of steady-state availability. To do this, we use the random variables x and y, characterize the mean time between failures, and also duration of system recovery. And then coefficient of steady-state availability can be represented by this formula. To find the statistical characteristic of the steady-state availability, we use the method of functional transformation of random variables. The probability density function is represented by the formula 9. And after some mathematical simplification, taking into account state technical standards of Ukraine regarding the technical maintenance of fire protection system, and according to this document, we know that the average system recovery time is approximately equal to 2,200 hours. We use the filtering property of delta function and transform equation 9 into equation 10. To find the statistical characteristic of the steady-state availability, we use the method of functional transformation of random variables. After mathematical simplification, we find the coefficient k and build the normograms for choosing the optimal ratio of the warranty period and time between failure.
Excuse me, Yulia, not the formulas. Maybe next slide.
I try, okay, да.
Yes, but
Sorry,
little format and
some
not
technical problem, yes.
no little problem.
By substitution, the numerical values using our normogram into the formulas 1 and 8, the function of the probability of failure-free operation of the loudspeakers of all 4 zones and failure-free operation of the image identification evacuation management system is obtained, and such result is represented in the next slide in figure 4. And according to calculations, the mean time between failures of the system is 8,105 hours. Here is represented the functions of the failure-free operation probability of image identification and evacuation management system, and the probability density functions of time between failures of our system. The statistical modeling was carried out for the above-mentioned set of initial data, and figure 6 shows that the simulation results confirm the correctness of the analytical calculations. And as a conclusion, I want to say that for the proposed security system project, the probability of failure-free operation of the system loudspeakers is much greater than probability of control indicator unit. So the probability of failure-free operation of our emergency notification evacuation management system is determined by the characteristics of control unit and it's quite high, despite of the short warranty period of all acoustic equipment. The article presents an approach to determining the statistical characteristic of the steady-state availability of security system, and this approach is based on the method of functional transformation of random variables. The calculation of the statistical characteristic of the steady-state availability for the studied variant of the security system showed such parameters as mean value of our factor and its standard deviation. Thank you for your attention.
Thank you. Very interesting report, but little presentation, but nothing. Any questions? No, I have little questions about this process evacuation. You told about probability, about statistical date, but for reliability of your system, which probability of successful results? The first question, probability of successful result in evacuation. And second question about statistical data. How you obtain statistical data? Where you obtain statistical data? The first probability for successful result in your system, and second about statistical data.
Okay, can I answer the question as a quota?
Yes, with together.
Yeah, together. Okay, first of all, about statistical data. So we have statistical data from enterprises that design these sensors and notification system. So we obtain the statistical data about failures, and we have some documentation for different equipment where we have the data about mean time between failure for this equipment.
And size of statistical data. This is a big data, or
no, not
this is a problem,
data.
maybe.
No, not big data, fortunately. And second one, so this we have data for failures, but data for process of recovery of serviceability, we have no this data, but we have the requirements of state regulatory documents. And we use these requirements, and using real statistical data and using the requirements for time of recovery, we try to find the statistical model of steady state availability. And we did it. And after the calculation for numerical example for some private building, we obtain the steady state availability approximately 0.8. What does it mean? This means that in each 5 case, we have failure of notification and emergency system in case of fire. So this is not good because we can have the risk of lives of people. So we make decisions that we have very bad requirements of state regulatory documents, because if you have some requirements, then enterprises that operates with the system will do nothing. So they will make recovery work only in case when we have exact time schedule. So because of this, we try to understand where this time was given. So we try to recalculate this necessary time. So in case of, for example, for radio equipment in aviation, we have the strong requirements for steady state availability that must be greater than 0.99. And in case of, for given example, for emergency system, we obtain the result that is equal approximately 0.7. So this is not
Yes,
good.
yes, I agree. This is important for enterprises too. Any questions?
Just a quick one. Thank you for a very interesting presentation. Yeah, just tying into the discussion, to the questions and discussion preceding, what do you see as a way to improve it? Just as you commented, Maxim Yurevich, that value seems to be needing an improvement. So what measures can you see as could be effective in improving this result?
The
Practical
improvement
operation.
is, yes, thank you. The improvement is new requirements in state regulatory documents. So the time for recovery must be significantly less. So we have the requirements for recovery for one type of equipment for 3 months, that it in case if it does not affect for the serviceability of whole system, but we can get many failures in the system, and if we get many failures, we can get the system failure, not only for one type of equipment. So the improvement is a new recommendation for time for recovery in regulatory documents in Ukraine. So it must be significantly less than now.
Understood?
Okay, thank you.
Serge, understood? Very interesting.
Yes, thank you.
Any questions? Not questions. Thank you. Very important. We have